All right, so firstly, I'm going to show you how to draw the Lewis electron dot structure for SeF4. The first thing you need to identify is which are the total electrons. Okay, how many total electrons are in the whole compound? So first we look at selenium. So you look at the column, okay? In your periodic table that I gave you, you've got these little Roman numerals at the top. That tells you how many valence electrons are in the valence shell. And so selenium is in group 6, so it has 6 valence electrons. So we'll put 6 plus. Fluorine is in group 7, and we have 4 fluorines. So 7 times 4. So fluorine has 7 valences and there are 4 of them. So now the sum is 7 times 4 is 28 plus 6, 34 electrons in total. We don't have a charge on this molecule, so there is no electron to plus or minus. Then identify which one is the central atom. So looking at the table, as you go from left to right, the electronegativity increases. But as you go down the table, the electronegativity decreases. So the least electronegative element goes in the middle. So selenium, since it is further down, it is less electronegative than fluorine. So selenium will go in the middle, okay? And then I just make the bonds to fluorine. 1, 2, 3, and 4. Each covalent bond that you see, one line here is a covalent bond where you've got 2 electrons being shared. Okay? And since fluorine has, firstly, fluorine has 7 valence electrons. We add the 7 for fluorine. So 1 here is fluorine's, 2, 3, 4, 5, 6. So now fluorine combined with the shared has the octet. 1, 2, 3, 4, 5, 6, 7, 8. It's got the octet. 1, 2, 3, 4, 5, 6, 7, 8. It has the octet. This one is the same. And then we look at selenium. Selenium's is 1, 2, 3, 4 that it shared, but it has 6. So you have to add a lone pair on selenium. So now we count. Do we have 34? I've got 8, 8, 8, 8. 4 times 8 is 32, I think. Plus 2 makes 34. So all my electrons are accounted for. Okay? So it doesn't matter that now selenium around it has 10. That's fine. You were taught that, yes, they must follow the octet rule. The terminal atoms, which are the ones surrounding the central, have to follow the octet rule. They must have 8 surrounding them. But the central atom does not. And when we get to the quantum mechanics of the atom, you will understand why. But the central atom does not have to follow the octet rule, but it must show its valences. So selenium's was this one, this one, this one, this one, this one, and this one. So there's 6.